USB Type-C power delivery profile, max length. The new USB-C connector allows for 100W to be delivered to charge laptops etc. Is there a maximum length for a charging-only cable? The specification talks about cables being less than 2 meters long. That seems really short. I know that data transmission over longer cables can be problematic, but is charging also restricted to maximum of 2 meters?
The answer is a definite maybe. I'll explain. USB Type-C is a special beast. It's a smart cable, with requirements beyond a standard USB cable. The specifications do not provide for a power-only cable, so the answer is really to the questions of how long can a compliant Type-C cable be, and can you have a longer non-compliant cable? Standard USB 3.0 cable. All of the wires in the cable are sized for the task they need to perform. The spec doesn't define a maximum cable length, it defines electrical requirements that must be met. One stated objective in the spec is that the cable be flexible. A range of wire sizes is suggested for each type of conductor in the cable, along with a recommendation that the smallest wire be used that will meet the electrical requirements for the cable length. The maximum cable length is based on the allowable losses using the largest suggested wire sizes. The USB 3.0 spec doesn't preclude making a longer cable as long as it can meet the electrical requirements. This can get expensive if the cable needs to carry signals as well as power. USB Type-C. Unfortunately, you can't make a Type-C power-only cable out of lamp cord. The current is spread over multiple contacts. USB Type-C is a smart cable. It has an embedded chip and a configuration line. The concept envisions the cable as carrying signals so devices can be daisy-chained, and the Type-C spec includes the data lines. A cable would not be considered compliant if it lacked data lines, although a manufacturer might be permitted to make a special purpose cable just for charging their own device, although the cable could not carry the Type-C logo. So any Type-C cable longer than the limit shown in that chart would be an expensive, custom cable. Safety standards. The 100W capability uses 20V at 5A. These levels have safety concerns, and the cable needs to meet some international safety standards. I have not been able to nail down the specifics of whether there is an approved configuration that limits the length, or like the USB 3.0 spec, there are requirements that can be met with longer cables. Bottom line? Probably the easiest way to get a definitive answer is to try to buy one. If you can find a longer cable from a reputable manufacturer, that will answer the theoretical question. The practical answer, though, is that even if you can find one, you probably would not consider it cost-effective.
My answer will not be as comprehensive as at Fixer 1234. But I wish to point out that the table you provided answers your own question. It says that power delivery 20V at 5A equals 100W is allowed with 4 meters cables, albeit only with USB 2.0 data transfer. That will change with hybrid fiber copper cables with the same copper for data transfer as the current 4 meters ones, but with fiber optics for data. There is finally a USB-C fiber cable with alternate mode DisplayPort, but I was told it is not yet available. This URL, active optical cable. There are several brands of USB-C 4 meters 100W PD USB 2.0 cables available, with the most prominent brand being StarTech. Anyways, if you must have even longer for power delivery only, then you can use the USB-C female to USB-C female adapters to attach two 4 meters cables together. I have found that PD always works with these couplers, but only with one orientation parity between the cables attached to the coupler. Either E markers or pull-up, down resistors, although not entirely sure that the pure USB-C cables use resistors, make the cable have a discernible orientation. The coupler itself does not seem to have any preferred orientation. You can flip it as long as the two cables go back and facing the same direction relative to each other. But it is outside of the specification, so exercise caution and common sense. If you go too long at high amperages, the voltage drop might upset the power delivery. Also, other non-compliant devices might do crazy things or malfunction. The compliant ones are generally able to handle dodgy devices attached to them, activate their overload protection and gracefully cease the interaction with the said device. So, just be cautious. The practical solution to your implied problem for now is to get a USB-C charger with detachable IECC 8 lead, Fig 8, which are usually thin because they are unearthed. You can get long ones of those. I know it is not much of a solution, but it might help until the USB have come to their senses and start defining requirements for performance, rather than limitations on other metrics. For example, instead of limiting charging cable length, they should allow and certify any cable with conductor resistance below some defined level. That way, a cable can be as long as fancied, albeit with larger and larger cross-sectional diameter of the conductors.